I'm also going to demonstrate number 57 because this is kind of a classic calculus optimization problem. And the situation is David has 400 yards of fencing and he wishes to enclose a rectangular area. So I'm just going to sort of draw this. We know he needs to enclose a rectangular area. And what we know is that any rectangular area is going to have a length and a width, and that's L and that's W, but he has 400 yards of fencing. So what I know is that 2L plus 2W is going to give me 400. And I'd like to get rid of one of these variables. So let's see, I guess I'll get rid of L. So I'm going to solve this for L. So 2L is 400 minus 2W. So L, in fact, is just going to be 200 minus W. So what I can do is I'm going to represent my rectangle a little bit differently. This is W, and this is 200 minus W. Now, here's the question. The question for 57 is we want to express the area as a function of the width. Oh, we should call the width x. Okay, so start again. So that's x. That's 200 minus x. But we want the area. And we know area is length times width. So we're going to have x times 200 minus x, or in other words, 200x minus x squared. So that's the area. And then they ask for what value of x is the area of the largest. Well, let's do exactly what we had done. Here I have a relationship between a and x. A is a function of x. Area is a function of x. So a is how I'm going to label my y-axis. So that's the area. And x is going to be the width, in feet, in fact, or yards. The other thing I know is that this function, I know what it's going to look like. In fact, in factored form, it's really easy for me to see what my x-intercepts are equal to. If I set that equal to 0, we'd have an x-intercept at 0, and we'd have an x-intercept at 200. Because I know about symmetry of a parabola, I know that the vertex is going to be somewhere on the axis of symmetry, which is going to be right in between, right where x is equal to 100. So this is a parabola that opens down, and in fact, very easily, I know that the vertex is 100. And if I plugged 100 in for my area, a of 100 is, well, that's going to be 100 times 200 minus 100 is another 100. So that's going to give me 10,000. Well, this is what I know. I know that for all his imaginings, how he can arrange this fence, I mean, 400 yards, we could have something like this. We could have 10 by 190, which is going to give us an area of 1,900, or he could have 20 by 180, which would give us an area of 2 times 18 is 36, so 3,600, so that's a little bit better. But what we know is that he's going to have a maximum area when the width is 100, which in fact would make the length 100, which in fact would make the area 10,000. So by looking at my graph of A versus X, what I know is that the value of X that is going to maximize area is 100 yards, and the maximum area is 10,000 yards. So the answer to the question would be, for B, the value of X is 100 yards, and the maximum area is going to be 10,000 square yards.